Okay, so we talk about we are talking about matrix multiplication. So, that we have seen using the standard method of matrix multiplication. If we have two matrix A B, which is basically size n cross n, and B matrix is size n cross n, and we have seen A C is basically A cross B, which is of size n cross n, and C I j is basically summation of A I k B k j. Okay. And we have seen the standard, this is basically using a for loop, 3 for loop, we can get this value, but that will take of order of n cube. This is the by the standard matrix multiplication formula method algorithm, standard matrix multiplication. Okay. So, now in this talk we want to see whether we can use some divide and conquer technique to reduce it further. I mean, whether we can apply some divide and conquer technique to handle this problem. So, for that let us just look at, so divide and conquer technique means if we have a problem of size n, it basically has 3 steps. So, this is the, just to recap. So, we have given a problem of size n, problem of size n. Okay. Now, in the first step, divide step, we divide the problem, this is the divide step, it has 3 steps. We divide the problem into lesser size, into sub problems, and sub problem size should be less than n. It could be n by 2, it could be n by 3. Divide the problem into sub problems. Okay. And then this is the first step of divide and conquer method. Then the conquer step, we conquer the sub problems by solving them recursively. We conquer the sub problems by solving them recursively. Okay. So, this is the recursive step. Again we have a sub problems, again we further divide into sub problems like this, until we reach to the size is 1. Once the size is 1, we must stop, because then it cannot be further reduced to sub problems. And then we have a final step, which is combined, which is the basically for merge sort, it is basically merge subroutine. So, we have a solution for these 2 sub problems, or 2 or 3, we have the solutions for the sub problems. Now, this merge step will this merge or combine step will combine the solution of the sub problems to get the solution of the whole problem. So, this is basically the divide and conquer technique. So, now we will see how we can apply this technique for our matrix multiplication method. So, for that let us just write the matrix into sub matrices. So, we have 2 matrix A B. So, we write the matrix is A as A B C D and B as say E F G H. Okay. So, these are basically sub matrices. So, these are all size n by 2 cross n by 2. So, A is n by 2 cross n by 2, B is also n by 2 cross n by 2. So, if we have big matrix, what we do? We just partition into 4 parts. So, this is basically A, this is this matrix, this sub matrix is B like this, sub matrix is C, and this sub matrix is D like this. So, these are basically sub matrices. So, we have 4 parts, we are dividing, provided n is an even number or n is multiple of 2, otherwise we have a lower ceiling or upper ceiling, but anyway this we will do the asymptotic analysis. So, we are allowed to do this floppiness. So, these are all sub matrices of size n by 2 cross n by 2. Okay. So, these are all n by 2 cross n by 2, these are all sub matrices. similarly here we have n by 2 cross n by 2, we have n by 2 cross n by 2, this is also n by 2 cross n by 2, n by 2 cross n by 2. So, this is basically just given a matrix, we divide into, we just think is a partitioning into 4 part. So, that is the way we represent this A B C D, and for B matrix E F G H. Okay. So, now we denote this. So, we are multiplying A into B. So, we are multiplying A into B, and A into B we are denoting by C. So, this is also we are writing in 4 part. So, like R S T U. Okay. So, this is also, this is n by 2 n by n cross n by n. So, C will be also n by n cross n matrix. So, this is also we partition into 4 part. So, these are all n by 2 n by 2. So, basically what we have this matrix multiplication R S T U is basically A B C D, then this is E F G H. Okay. So, this is the matrix multiplication, and these are in the submatrix form. So, now what is R? R is basically, so we have to write this formula. So, what is R? R is basically, R is getting by this into this. So, R is basically AE plus, these are all matrix multiplication, these are submatrices, plus BG. Okay. So, these are all, this is n by 2 matrix, this n by 2 cross n by 2, this is also n by 2 cross n by 2, this is also n by 2 cross n by 2, this is also n by 2 cross n by 2, and this addition is matrix addition. So, we have 2 matrix of size n by 2 cross n by 2, we add it. So, just the addition of the elements, corresponding elements. So, similarly, we have S equal to, S is basically this cross this. So, AF plus S is AF plus BH. So, these are all matrix multiplication, these are all matrix addition. So, T is similar to, T is basically, T means T is basically this into this. So, CE plus DG, C into E plus, so this C is nothing to do our this A into B is equal to C, this is capital C. So, better we use this in different notation. So, do not confuse with this C and our matrix C, okay, they are different basically. So, basically we have 2 matrix A B, this is A matrix, this is B matrix, and the multiplication is this matrix. So, this is capital C. So, this two C are not same. So, if there is any confusion, we can make it to some other matrix W. So, A W is equal to A cross B, if there is any confusion with this C, but anyway this is small c, that is capital. So, C into E plus D into, so this into this into this, D into H. So, T is basically this into this. So, C into E plus D into G. Okay. So, and then last one is U. U is basically this into this, C into F, C into F plus D into H, D into H. So, this plus are all matrix addition. So, this is the formula we have. Okay. So, matrix multiplication is basically, so this is the divide and conquer step, this is the divide step. So, now what is this? Now, we have the matrix. So, we earlier we had to have multiplication of matrix this cross. So, we have a matrix, we have a B matrix, and we have to multiply. This is of size n cross n, and this is also of size n cross n. Now, here these are the all matrix multiplication, but these are all lesser size. What is the size? These are all n by 2 cross n by 2. these are all n by 2 cross n by 2, all the matrix multiplication. So, these are the sub matrices. So, these are all lesser size. So, this is the divide step. We divide the problem into sub problems. Earlier our problem was to multiply two matrix of size n cross n into n cross n. Now, we reduce the problem into sub problems, like now we have to multiply n by 2 cross n by 2, and another matrix is also n by 2 cross n by 2. So, that is the divide step. And now, by in conquer step we must get the solution of this and we must get the solution of this. Once we have the solution of these two, then we have to combine by adding this to get S. So, that is the divide and conquer approach. Is this clear? So, basically we have a we have two matrix, we reduce the matrix into sub matrices, and then we reduce the, so that means we reduce the problem into sub problems, and then conquer step we again call the same formula. Now, this is of size n cross lesser size, again we call further divide into sub matrices like this, and again once we have a solution for this, once we have a solution for once we have a result, and once we have this result, we add this, and that is a part of the combine step. Okay. So, how many matrix multiplication we are doing? Basically we are doing 8 multiplication. Okay. And how many addition we are doing? We are doing the 4 addition, 4 matrix addition. These are all matrix addition. These are all matrix multiplication of lesser size. So, now what is the recurrence we have? So, basically every divide and conquer technique have the recurrence like Tn is equal to, so for Mart sort we have, if you remember, for Mart sort we have the recurrence Tn is equal to 2 Tn by 2 plus theta of n. So, this was the so we reduced, we have a problem of size n, we reduce into the sub problems, and these are the number of sub problems. This is the Mart sort recurrence. This is the number of sub problems, and this is the size of sub problems. Size is reduced to half. I mean, we have an array, we divide into 2 part, half half. This is the size of sub problems. And this is the cost for both divide and margin and combine, divide and combine. So, now if we use this divide and conquer technique of matrix multiplication, so then what is the recurrence we have? So, we have Tn is basically how many sub problems? So, our problem is basically matrix multiplication. So, we reduce this into sub matrices. So, how many sub problems? So, now we have 8 sub problems, because 8 matrix multiplication is required on the lesser size. So, that will be done in the conquer phase. So, that is 8 of T of size, this n by 2 is the size of the sub problems. Now, our problem was n cross n matrix multiplication. Now, it is n by 2 cross n by 2, and both the matrices, sub matrices. So, size is reduced to half. So, that is the size of the sub problem. So, this is basically n by 2 plus the cost for what? Cost for combine. So, combine means this additions, this matrix addition. So, how much time it will take to add 2 matrix? So, that is the point. So, that is the time to take the addition. So, how much time it will take? So, 2 matrix addition. So, what is the size of this matrix? So, once we get the result this by the conquer step. So, this will be a cross E will be a matrix of size n by 2 cross n by 2, okay. And then B cross E, this is also of size n by 2 cross, sorry, n by 2 cross n by 2. Now, this addition means we are just adding the, this is added with this like this. So, if this is a matrix like x 1 1, x 1 2, x 1 n by 2 like this, and this is y 1 1 like this. So, this is basically addition is y I. So, addition will be z I j, z I j is basically x I j plus y I j. So, we are adding just adding the corresponding entity, matrix addition. So, just we take this value adding with this value adding with this like this. Even you can think this as a vector. So, just this is a vector of size. So, just first row, then second row, third row like this. So, this is a vector of size n square by 4, and then this is also a vector of size n square by 4. So, we are just adding two vectors like this. So, if we add two vectors, then it will be. So, how many addition? We have basically n square by 4 addition. So, this addition will take order of n square. So, each addition will take order of n square. So, how many addition we have? Each of these addition will take order of n square. So, we have basically 4 such addition. So, if you have 4 addition, so this will take order of n square. Okay. So, this is the cost. So, this is basically number of submatrices. This is the recurrence for matrix multiplication using this divide and conquer technique. This is the number of submatrices. Basically, we are having 8 submatrix multiplication, number of submatrix multiplication, and this is the size of the submatrices. Submatrix size is reduced to n by 2 cross n by 2, size of submatrix, and this is the cost for combining the addition, addition for submatrices. Okay. So, this is the recurrence we have for this divide and conquer technique. So, now we want to know the solution for this recurrence. So, this is basically so we have this recurrence. What is the recurrence? T n is equal to 8 T n by 2 plus theta of n square. So, what is A? We want to fit it into master method. We want to see whether this. So, A is 4, B is 2, and f n is n square. So, which case we are in? So, n to the power log A base B, this is basically n cube. So, we are in case 1. Okay. So, case 1. So, what is the solution? So, solution is this term is dominating. So, this is asymptotically polynomically faster than this one. So, this is basically order of n cube. So, this divide and conquer technique is giving us order of n cube time algorithm, which is not better as the standard method of matrix multiplication, because standard method is also giving us order of n cube. So, then the point is how we can modify it further. So, that is the idea of Strassens. So, Strassens gave the idea of how we can modify it further, like because this direct divide and conquer technique will give us order of n cube algorithm, which is same as the standard matrix multiplication algorithm. Okay. So, the idea of Strassen is like this. So, instead of this recurrence, suppose, so this is the recurrence coming from this divide and conquer technique. Suppose instead of 8 multiplication, if we can reduce a multiplication by 1, instead of 8 multiplication, if we can reduce it to 7 with the cost of more addition, because addition anyway will take order of n square. So, here we are doing 8 additions. What is the formula? Formula is our R is basically A plus B G, our S is A plus B H, our T is basically C plus D, T is basically C plus D G, and our U is basically C A plus D H. So, this is the R S T U. Now, here we are doing 8 multiplication. So, the Strassen's idea is if we could reduce 8 multiplication, instead of 8 multiplication, if we could reduce to 7 with the cost of more addition. Here we are doing 4 addition, but if we could do more addition, that will be captured under order of n square. So, that will not affect much. So, that is the idea. So, that is why we want to make it, the Strassen's idea is to make it 7 matrix multiplication. So, that is the, so that we are going to write how we can do that. So, that is the idea by Strassen's idea to reduce the multiplication by 1 with a cost of more addition. So, for that Strassen is calculating some intermediate terms like P1 A into F minus H, P2 into H, P3 is basically CD into E. So, I will explain. So, these are the terms we are calculating, these are intermediate terms. So, there will be 7 terms. So, that means there will be 7 matrix multiplication, but we will have more addition. So, we will talk about that. So, D into G minus E, and P5 is basically A plus D into E plus H, and P6 is basically B minus D into G plus H, and the last term is P7. P7 is basically A minus C into E plus F. So, these are the terms Strassen is calculating, these are the intermediate term. So, there are basically 7 terms. So, that means 7 multiplication of lesser size. So, this is multiplication with. So, once we get this value, how to get R S T U? So, that formula we have to write, then we can see R is basically P5 plus P4 minus P2 plus P6, and S is basically P1 plus P2, T is basically, we can verify this, P3 plus P4, and U is basically P5 plus P1 minus P3 minus P7. Okay. So, with the help of this PIs, we can get this. So, how to verify this? We can take one example like this one, remaining you can check by yourself. So, P1 plus P3. So, P1 plus P2. So, P1 is basically this into this. So, P1 is AF minus AH. Now, what is P2? P2 is AH plus BH. So, AH plus BH. So, these two is cancelling, AF plus BH. What is AF plus BH? AF plus BH is basically S. So, this is verified, S equal to P1 plus P2. So, the remaining term also you can easily verify just putting the value of P's. So, this is the formula. This idea is given by Strassen. So, basically instead of 8 multiplication, we have 7 multiplication. See, there are 7 terms and each term is having 1 multiplication, but with a cost of more addition. This subtraction is also addition. So, with a cost of more addition. So, how many addition? Subtraction is also addition, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then 11, 12, 13, 14, 15, 16, 17, 18 with 18 addition. So, we have 7 multiplication and we have 18 addition. That is okay, because addition can be more, because addition will take, one addition will take order of n square. So, this will be captured in theta of n square. Then what is the recurrence of this method? So, recurrence will be, we have 7 multiplication. So, that is the good news. So, Tn to be 7 Tn by 2 plus order of n square. So, this is the recurrence we have for Strassen's matrix multiplication method. Here we have more addition, but that will taken care by order of n square, and we have only instead of 8 matrix multiplication we have 7 matrix multiplication. So, these are the term is this. So, then what is the solution? What is the solution for this? So, here A is 7, B is 2, f n is order of n square. So, what is n to the power log a base b? It is basically n to the power log 7 base 2, it is basically n to the power 2.81. Okay. So, now this is also in case 1, and the solution for this is basically T n is equal to n to the power 2.81. So, this is the time complexity for Strassen's matrix multiplication. So, this is much more better than the n to the n cube, which was the standard method or just the divide and conquer technique. So, this is also divide and conquer technique, but we could reduce the matrix multiplication by instead of 8 we could reduce to 7. So, this is a good gain in terms of this. So, this is the Strassen's idea. So, next problem we will talk about VLSI layout, which is the another problem which can be used in which we can use the divide and conquer technique. So, this is the different problem. This is not really algorithm problem. This is called almost 5 minutes VLSI layout. So, the problem is, so we have a chip, a rectangular chip, and we want to embed a complete binary tree. This is the problem. Embed a complete binary tree with n nodes, n leaves in a grid using minimum area. That is the problem, using minimal area. So, we have a rectangular chip. So, in which we have to embed a tree, complete binary tree like this. So, this is the tree. So, maybe once more. So, this tree we have to embed in a chip, a rectangular chip. So, we have the rectangular chip in a grid. So, that it should take the minimum area. So, area means this is the length, this is the width. So, the total size will be less. So, this we can do it like this. So, we can just start it. This is the naive approach. So, what is the naive approach? So, this is the problem. So, the naive embedding. Okay, so we start embedding this. So, this is so we start from the so then this is basically so this is giving us like this. Like this, then again we take this, again we take this like this. Okay, so this is the naive embedding. So, we just start with this leaf node, then we slowly, this is the root. Okay, now this is our chip. Now, what is the length of this? How to calculate the area? So, if we denote this by the height of the tree, and if we denote by this width of the Wn, Now, for height, what is the recurrence? Height is basically, so this is a, we have to embed n nodes. So, to embed n nodes, we just, so these are running in, these are in parallel. So, height for recurrence for height is T n is h n equal to, so h n by 2 plus theta 1, because these two are in parallel, but for width it is not parallel. So, this will count. So, basically for width we have W n is equal to 2 of W n by 2 plus theta 1. So, if we again use the master method, this will give us a solution like log n, but this will give us a solution like n. So, the area is basically, so the area is height into into the width. So, area is basically order of n log n. So, this is the naive one. Now, do we want to make it in a order of n times n, we want to do it in order of n. So, that should be the area we want. So, for that we will do something which is called H embedding, H tree embedding. So, how to get order of n? To get order of n, and height and width should be order of root n. So, how to get root n? Which recurrence can give us the root n? So, if we have a T n is like this, T n is equal to say 2 T n by 4 plus theta 1. So, this type of recurrence will give us root n. If we can show that the height and width are both are coming like this recurrence, then we are done. So, for that we will have H type embedding. So, what is that? We will do like this. So, these are all, so these are all H, this is called H tree. So, we are drawing the this thing and another one here. Okay, another one H tree here. So, these are all the connections. So, these are all H tree. Then we have a this one, then we have this one. Okay, so these are all H tree, H structure. So, if we have this, then this is basically L of n, and this is basically, this is also same, this is also L of, this is basically width. Now, what is the area? So, this is we are L of n by 4, and this is theta of 1, and this is again L of n by 4. Okay, so, we have a recurrence for L is like this, 2 of L of n by 4 plus theta of 1. So, this will give us a solution theta of n. So, this is the one side area. So, length, and the area is basically root over of this. Okay. So, this is the using the help of H type embedding. So, this is one application of divide and conquer technique in totally in different area. So, this is called VLSI layout. We want to fit a, in this chip we want to fit a complete binary tree connection. So, that is the idea. Thank you.